My name is Alex, and I'm going to speak today about this super exciting topic, which is building scalable cloud-native geospatial applications with CARTO and deck.gl. This is so exciting, and we share a lot of content around developers, so follow us for more resources like this one. But all in all, I hope you enjoy this webinar. As I said, I'm Alex. I live in Madrid, and hello everybody. I know we have people from different parts of the world today. I'm a senior product manager at CARTO, and the areas that I work on are everything that has to do with the core of the platform and specifically for CARTO for developers. So feel free to ask any questions about, APIs or how CARTO works or how CARTO is built, and I'd love to answer those. But of course, today we are talking about developers. So anything that has to do with our development tools, I will be very happy to speak about that. And the agenda for today. First, I'll do a brief introduction and I will talk a bit about why we think this is the best approach for large-scale geospatial application development in the modern data stack. I think today we're going to talk about technologies in a way that makes sense for the current times, in a way that leverages the latest technology, both in geospatial, but also in computing technology. And then we are going to get hands-on. I hope you will follow me along while I build some large-scale visualizations just using CARTO and deck.gl. Don't worry, we are not going to go into a lot of detail, but we are going to show some maps and hopefully some cool demos. Lastly, I will try to cover a bit of the roadmap that we have in the product, and we'll leave some time for questions and answers. So actually, so I can adapt a bit this webinar, I would like to ask all of you, how fluent with coding are you? If all of you are, front-end engineers, then let's go ahead and let's make this very technical. But if I need to adapt the tone a little bit, I would love to know. And actually, I like knowing that I have people in the other end of the screen. I already saw some people in the chat. So if you can answer this poll, that would make me super happy. I will let you answer for 20 seconds, and then when everybody's ready, we'll show the results. I added some middle options. I hope that reflects the reality of your role. And we have results. All right, seems that most people do some coding, at least if not on a daily basis, every now and then. So let's get to it. Thank you so much, everyone. First of all, I wanted to speak about what is a geospatial application, or what makes an application geospatial. So typically, if we think about a geospatial application, it's something like what we see in the screen. This is our site selection tool. It's defined because it visualizes geospatial data. It has a map. It is map-centric, maybe, and it analyzes the data. People tend to think about maps as something you just view on the screen, looks super cool, but for us, the analysis is super important. It's actually what is really happening in the map, and the insights that you can get. But it's not just any geospatial data. What we see from a lot of companies is that you have terabytes of data, and this is growing, that you have raster data, that you have vector data. Some of this data comes from very powerful modeling and prediction analysis. And of course, there's the whole branch of spatial data science that uses this geospatial data for super advanced insights that relate to the business. And then we have other types of data that is also growing. It's in the order probably of petabytes by now, and it needs additional things like geocoding and aggregations. Geospatial application means that it needs to be built by someone. So you have other software that you integrate, you have your developers and data teams, and you have your own technology stack. I feel that's super important when we talk about a geospatial application. But even more important is, what are you achieving with that geospatial application? So you're getting value for end users, you're getting value for the company. And I'm just saying this because I don't want to just speak about JavaScript and code. I want to speak about all these things. I want to make sure that whatever we are building today brings value to your end users, brings decision-making, that it is super performant, that also and ultimately brings value to your organization. So I was thinking that these topics have been constant over the years, but the answer for each of these topics is different almost every decade. What do these look like in 2024? What we see is that companies, especially enterprises, are now storing their data in the cloud data warehouses. So of course, everybody's using the cloud, and I'm not saying that these are the only ones, but these are the ones that we see more commonly. Organizations in Google Cloud use Google BigQuery. Snowflake is super common for organizations of all sizes. Then we have AWS with Redshift and other databases. We have Databricks, and we have Postgre that has been always our favorite for geospatial until very recently. But there's more. Of course, there's other databases, and of course, there's data providers that have premium and public data sets. Of course, there's a lot of open geospatial data. And we have things like Google Earth Engine that provide super valuable data for this analysis. On the integration side, we have things like Google Maps, we have custom-based maps, we have geocoding and routing. And these are the geospatial parts. But when we talk about this application, we have to think about what technology are your developers going to use? What stack do you already have? If you notice in the screen, there's a lot of things happening that are just not the map. Are those built with Angular, with React, with plain JavaScript and TypeScript? And ultimately, those things affect the value for end users and for the company. So I wanted to put this picture, and maybe if you want to let me know what you think, but I wanted to put this picture so we put all the code that we're going to make in context. And that will help me explain why CARTO and deck.gl is a very good answer to that picture. Let me speak a bit about CARTO first. We consider CARTO to be an end-to-end platform for cloud-native geospatial analytics. Cloud-native, it means that we incorporate those databases at the very core. We push all computation, and you'll see in a minute, we push all that computation to these cloud data warehouses. And then we offer different solutions. We have Data Explorer, we have Builder to create maps, we have workflows for analysis, we have analytics toolbox, which are functions that you can run on top of your data. We have our data marketplace, which is the data observatory. And of course, today we're going to talk about CARTO for developers. And we think this is almost a new paradigm. When we were talking about how the answer to all of those questions change every decade, before for geospatial data, we had this sort of ADOC databases. Then CartoDB also was a path forward, but the numbers are impressive. What we see is that running geospatial on top of BigQuery or Snowflake means automatically, 10 times more scalable or 100 times more scalable. We have some comparisons, and we see that, trying to build tilesets with ArcGIS, desktop, or other tools for a 200 million polygon tileset takes orders of magnitude more time, and it's orders of magnitude slower than trying to do it with CARTO and BigQuery. So of course, there's always trade-offs, but this is almost for us like a breaking change that cannot be compared with other technologies. It's just faster and more powerful and more scalable. And it has an added benefit. Data is already in the cloud. So by not having to build ETLs, by not having to take it out, you are basically saving your teams from building those ETLs and having to maintain them. So we love this approach. Of course, it's ours, but we think it has a lot of benefits. I'm going to review now deck.gl. Deck.gl is the other part of the webinar today. Some of you might know deck.gl was born in around 2015, and it was created in Uber as a JavaScript visualization framework. It was then made open source, and since a few years ago, it's actually one of the leading data visualizations library on the web. It is designed to be super performant for large datasets. It's actually how it's designed. It's why it was born. And it uses WebGL and more recently WebGPU. We'll talk about that. to create those visualizations in your browser. Two concepts that I want to highlight. One, it has a layered approach. So when you're building with deck.gl, you are building layers. And these layers are super flexible and they make integrations like Google Maps super easy. It uses a reactive approach. So this is super compatible with how the web works today and how we all build our applications. If you use React, you are familiar with this. If you use any other framework like Angular or Vue or Next.js, you are probably familiar as well. And even better, you don't need a backend to serve these maps. All can be done in the front. CARTO and deck.gl are very coupled. We'll see that in action, but to develop geospatial applications with CARTO, you will use deck.gl for visualization. And honestly, it's a pleasure. The latest release for deck.gl and major version is version 9, and we have a CARTO blog post about it, and we are super excited. One of the things that I love is that we are probably the first geospatial visualization library to integrate WebView. And we don't have now the time to make a WebView webinar, but WebView is almost the next generation or the future of web rendering in the browser. So super excited about this, and honestly, this speaks about how we consider deck.gl the future of geospatial visualization tools, and we are fully investing in deck.gl. The architecture of CARTO and deck.gl looks something like this. You have your existing cloud, you have your existing data. The CARTO platform sits on top, and we have a set of APIs. We have maps, SQL, and then we have other APIs that solve common tasks. deck.gl is something that is almost a dependency that will solve all the visualization needs. And then the application layer, you control that, you choose the technology. These are four that are very common, but it almost can be anything that you want. So it's very simple architecture, and in my opinion, it doesn't have a lot of dependencies. It just needs CARTO and deck.gl. In theory, you should be already using a data warehouse. If not, CARTO can provide one. In deck.gl, inside deck.gl, we have three main components, at least from a CARTO perspective. You have the core deck.gl functionalities. You will always be using these. You probably need to get familiar with the concept of layers, with the view in deck.gl, with the different classes in deck.gl. Then there's other deck.gl functionalities, has extensions to interact with the terrain, to interact with the map, to do different views, and all of those are kind of optional, but they allow you to create incredible full-blown interactive solutions. And then we have the CARTO module. This is the submodule that we created and maintained, and this is what connects all the pieces. So if I go back, all those arrows are the CARTO module, and they are what makes everything super easy to build. One example, and then we'll do some live visualizations. The structure of a deck.gl version 9 plus CARTO code looks something like this. You of course need to import the different modules from the library. Then you set up the credentials. Then you set up sources, and we'll explain that in a minute. You configure the deck instance, and then you use those sources in layers. So your layers are the final visualizations. We'll see more of this code later, so no problem. Let's review those sources and layers, and we are getting into the detail now. Source types. CARTO accepts vector types, vector sources. So any points or polygons. CARTO also can work natively within the warehouse with spatial indexes. If you're not familiar with the spatial indexes, please, that might be something for your to-do list, and we'd love to help because they are super powerful in terms of scaling up visualizations. We have support for H3, and we also support Quadbin spatial index sources. Then we have boundaries, which is something I'll explain later. And we have, of course, raster sources as well. So temperature or elevation or vegetation index or any satellite imagery will likely come as a raster source. Those sources can be used in layers. So for vector data, you have vector tile layer. For H3, you have H3 tile layer, and so on. And then lastly, for raster, you have raster tile layer. If you've noticed, we use tile layers. And you'll see later, but this is our approach to large scale visualizations. You don't load all the data in the computer. You just load only the tiles that you need at that moment. CARTO takes care of the tiling dynamically or statically, but you'll see that we will use millions of points, millions of polygons, billions of rows will be used in this demo. Going back to the previous diagram, this is what my opinion or my picture of a geospatial application looks like. The vision that I have and the vision that CARTO has is that CARTO plus deck.gl solves all the hard part, does all the heavy lifting connecting these concepts so that you can focus on your application. Whether that's bringing value for your end users, whether that's bringing value for the company, you should be focusing on that and not on connectivity, not on integrations, not on learning a new framework, etc., etc. So super excited about this. We're going to go into details and I'm going to do some coding. If you have questions, we have a Q&A section, I believe, in the webinar. Please send your questions that way, and we will answer them at the end of the webinar. Thank you. Let's build something. I'm going to stop, and I will. So, CARTO. This is the CARTO interface. Some of you might be already familiar with it. I'll actually slow down just so that people that might not be familiar can follow this demo. CARTO starts with a workspace, and the workspace is where everything else happens. Then we have maps and workflows. With maps and builder, we can prototype maps, and those maps are super easy to create. With workflows, we can quickly build analysis in a no-code environment, and that is super easy to use. With Data Explorer, I can explore all the data in our cloud data warehouses. So I'll open my connection and we'll show this data set. So this is all the data that I have in my own data warehouse. This is Google BigQuery. I will use Google BigQuery today, but we could also be using a Snowflake, Redshift, PostgreSQL, etc. With Data Explorer, it's super easy to just preview data. So if I open this data set, 1.4 million rows, load super quick. The preview is super easy to use. Of course, this preview doesn't have much information, but of course I could use Builder, CARTO Builder, or CARTO Workflows to do things with it. Data Observatory, we have a marketplace of data. This includes both public and premium data. You can use this data also in your maps, in your workflows, and there are more than 10K data sets. So if you need, demographics for the US or, environmental data sets from anywhere in the world, you can find them through CARTO. Something interesting is that we don't just upload this data to CARTO, we will deliver this data to your data warehouse. So if you're using a Snowflake and you want any of these data sets, we'll put it in your Snowflake. CARTO is cloud native, so we can create connections to all of these data warehouses, and it works. We push all the computation down to it, and the integration is super tight. Applications and developers, this is what we're going to be reviewing today. And then we have settings that allow you to do any other action. Now, for developers, I will show you this repository of examples because what I will do is I will start from one of these examples. I will share the link later, but this repository of examples, anyone can access it. And today we are going to start from the hello world. All of the examples have a usage. Of course, you can run it locally, but I'm going to use StackBlitz so that you all can view what I'm doing. If you have used StackBlitz before, great. If not, it's basically a tool that I can instantly create an environment, and I have both the preview and the code in the same screen. So for the purpose of this webinar, it's actually great. And this is the hello world example, super easy. We are going to first, and actually I didn't want to open this one, so I wanted to start with the query parameters. I'm going to start with a more advanced example, but then I'm going to adapt it. So same concept, I open that example, and now I'm opening StackBlitz, and I will have the example working in a second. What this example is doing is it's showcasing some rail accidents from, I think it's 2012 or 2010 to 2013. And I know we are grouping them by state and also showing the actual accidents style by damage. That's not the demo I want to build. I want to play around with some datasets, but I'm using this one as a starting point because it actually contains some of the HTML. So what I need to do is start here, and this will be our webinar. I don't need this. I don't need this either, but I will need the input. And we can take this out for a moment. Then on the deck.gl side, everything is going to be in this file, the index TypeScript file. And we are using TypeScript, so you'll notice that we have a lot of suggestions. We'll have this sort of automatically autocomplete built in. It's super comfortable. So as we discussed before, first of all, we have the import structure. As you can see, we are importing map libre for the base map. We are importing the deck.gl. And then from the CARTO module, we are importing the necessary modules for this visualization, these four. Then we are importing our credentials. And actually, this is the first change I'm going to make. We are going to get new credentials, and we are going to set them in this example. To generate new credentials, let me go to developers. And then I will create an API access token. An API access token is sort of a API key that grants access to a specific API, to a specific resources, and for specific restrictions. It is super simple to use, super easy to use. So this will be my webinar token. I'm going to use the Maps API. I'm going to use the SQL API. I'm going to use all the APIs just in case. This API token does not have access to all data. It only has access to the data that I choose. So for this webinar, I'm just testing around. So I will choose my connection, and I could select a specific query, but I'm going to select all sources. Of course, this is not perfect for production, but in this case, I think it's fine. So let's allow that. And I could restrict the URLs that can use this token, but for this example, this should be fine. I have now the new token, and I can just copy it from here. Nice, we created our token. We also have the API-based URL. In our case, is the US region, but in your case, it might be different. So please take a look at that. And I just need to replace it here in the environment. Nice, we have a new token. I'm sure it's not going to work. During this demo, you'll see things not working quite frequently. That's fine, I'm so sorry. Changing code live is risky. So let me now change this section. I'm not using this connection anymore. I think I'm using this. And just to double check, okay, data is there. So that's great. We did the first thing. We created a token that works, and we granted it access to a specific data connection. Then I'm defining deck, and there are different ways to do this. This is how I do it. I first create the initial view state that has the typical variables, and if I wanted my application to load closer, I could do it this way. For now, this is fine, but I want some 3D here. Great, then I'm starting deck. I'm also starting the base map. Base map dark matter is a CARTO base map. You could use other base maps, and you could use other styles from CARTO. Let me change this if you want it, but for this, I think dark matter with maybe no labels would be better. Then this piece right here makes sure that the base map stays synchronized with the data. As we explained, deck.gl uses this kind of layered approach. So with this part of the code, we make sure that that is happening. This part of the code manages the input. I'll change this in a minute for my demo. And then I have a render function here that basically what it's doing is creates all the sources, all the layers, and finally adds the layers to deck. And then the application starts, deck.gl is loaded with the render function. So I want to build a complete new application, so I don't think I need this. Let's start from scratch, shall we? Let's start from scratch. No sources, no layers. Let's register our first source. So the first source that I'm going to bring into this application are some polygons that in Madrid, around Madrid. So I can use Data Explorer to find that data source. This one. Demo effect right here. 1 second. Yeah, there we go. So I wanted exactly this one, buildings in Madrid, which I think originally comes from OpenStreetMap. We'll use that later too. Okay, we can probably get that by memory. So, well, that loads. If not, no problem. What we'll do is we will create a new source. So this will be our Madrid building source. No problem. And then this will be a new vector table source. As you saw, TypeScript is helping us here, and it's automatically completing all the parts of the modules. So new vector table source, and this expects the CARTO config that I have up there. And then it expects the table name, which I have here. And this is the table name that I wanted to get from Data Explorer. Sorry, I don't need the new here. All right, so that is my source, but the source is nothing without a layer. So let's create a layer. Now we need to create a layers list, an array of layers. And the first layer that we're going to have is the vector tile layer with our buildings. So we give it an ID. Let's call this Madrid buildings as well. And this is the important part. We give it a data. So the data is the source, and that source is Madrid buildings. We want it to be pickable, which later I could use to create tooltips and things like that, or effects when I click in the source. I'm going to make it slightly not full opaque. And I'm going to just give it a plain color for now. So let's style this very easily. I can also style the borders, the contours of the polygons. So I will make them white. Of course, we could spend all the webinar styling this. For now, let's just make sure that this is relatively visible, and I'm gonna make sure that it's visible. So that should be it. I have no errors. So let's go to Madrid, and our data should be somewhere here. There we go. Now, this is not a small data set. It's not huge. We're going to bring a larger data sets, but notice how quick it loads. It automatically generates the tiles. And this is happening because CARTO is bringing this data from BigQuery with a process called dynamic tiling. So all this data is coming in tiles directly from BigQuery. And when I zoom in, I have all the details. When I zoom out, I don't need as much details. So CARTO leverages all the resources available and automatically creates dynamic tiling. I didn't have to do anything. I just registered my source and my layer. So that's awesome. And of course, I could do this in a different color, but we likely, yep. So that's really super interesting. We have all this data here. I want to do a bit more data, and I want to bring maybe millions of points. So I will register a different source. This is gonna be points from OpenStreetMap. But now I'm not going to bring the entire table. I'm going to bring a specific SQL query. So instead of table source, we're using query source. Let me make sure that we have imported this. There we go. And now it's very similar. We bring the credentials to this source. And now we need the SQL query instead. So I have the SQL query here. One second. I have my SQL query here, and I want to highlight something, which is this SQL query is filtering this data. So I'm selecting all points from this data source where the group name equals the input, and we'll go about that in a minute. Lastly, because we are using a query parameter, I want to register that query parameter right here. And then this is complaining. One second. Oh, because I did it on the wrong one. Apologies. Okay, that's better. Okay, now we have our source, but our parameter isn't ready. So what I'll do right now is I will update this. I am like a chef. I have this pre-cooked. So I I hope you don't mind that I copy and paste, but it's the same concept. It's just that we have a selector. And then in this one, I'm also going to replace, but I wanted you all to see that this is coming from a live example that I just modified the values. So I use this one. And then I'm not choosing a year, I'm choosing a category to filter. So we have three categories. We have financial, education, tourism. Financial is the first one, and it's the default one. So this input start, or this query parameter starts filtering by financial. Let's create the layer now that uses that source. So new vector tile layer. This is gonna be our OpenStreetMap points. Also coming from that source. And same thing. I will just maybe make it blue. So 1 second. Let's do this. And I want to maybe add a minimum point radius, minimum pixels. Each point will at least be 2 pixels wide. And of course, I want this to be visible. Okay, that wasn't so hard. And we are visualizing a lot of points. Originally, this table is 1.4 million points. So this is not such a small table. Of course, a million points can be visualized in other ways, but we built a dynamic visualization with filters that are powered by Google BigQuery. We built it in almost like a minute. So if I now choose education, I would still need to work on the loading stage, but I can already filter by education. And as you see, the dynamic tiling is taking care of all the zoom levels. No problem. I can filter by tourism. And as the new data comes, the map is automatically filtered. There's nothing I did before this demo. This data is a table in BigQuery. And, this is amazing. This is just something that looks easy, but it wasn't easy for us to develop. And now it's easy for all developers that are using CARTO and deck.gl. So this is the first milestone of our demo. We built a map that is actually filtered by an input. And all of this is happening in Google BigQuery thanks to CARTO and deck.gl. As you can see, the performance is very good. Let's move on. Remember that questions and answers, please, there's a section for that. If anybody wants to just hop in the chat, that's also good. Let's create another source. And I'm going to do spatial indexes now. So a spatial index is just a way to put geospatial data in a grid so that it's much more performant, and it's aggregated into a grid, and you can do much more things with that data that if you had the data just raw in points. So we'll see how that works. And what I'm going to do is I'm going to create another source. So this Quadbin query source. Quadbins are squares, while H3 are hexagons. So for this one, same concept. I bring the credentials. I bring a SQL query. I did query source, right? Yes. So I have my SQL query somewhere. So this is derived special features. This is a data set that you can also find in your CARTO account. And I need two more things. I need to tell CARTO and deck.gl how this data is going to be aggregated. So I need to tell it the aggregation expression, which is something like, if you are zooming out, please zoom the values for each squares. And I'm going to do some population as value. And I can select the resolution that this aggregation is going to happen. So I will start with 8, and I think that will be a good start. Again, I have my source. I can do my tile layer. Now I'm going to skip one step for the sake of time. . 。 . 。 . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Quadbin tile layer. I need to import this first. So let's go here and add our Quadbin tile layer. There we go. Same thing, we have an ID, we have the data, we have the opacity and all things. And for the first time, I'm using the 3D. So I'm extruding these squares to get some height. And I'm using a very cool function from the CARTO module, which is styles. I can use color bins or color continuous, and based on the value, which in this case is population, I can quickly select a scale from the CARTO colors, which I should have here. I can select this one and just use them here. So purple. And then the domain, for now, I'm doing a static domain, but I could use any dynamic domain, any dynamic range. Let's move to Spain. We are not seeing that right now, but if we go to Spain and we put this to visible, we have now a very performant, very cool Quadbin based visualization. Let's make this so that it focuses on Spain for now. Great. Again, what we're doing here is not just plotting some points or polygons in a map. We are dynamically aggregating millions of rows into these special indexes. And directly from BigQuery, we are bringing this data in tiles. CARTO is doing all the heavy lifting so that you get this awesome visualization. As you can see, it's super performant. It doesn't require loading times. There's also a cache layer on top of this data, so you don't request the same tile twice. But the concept here is how easy it is to build this sort of visualizations. If I wanted to, I could bring tooltips or I could bring legends to this. Very, very excited about this type of visualizations. Let's go even further. I don't think visualizing, Quadbins in Spain is enough. I actually want to visualize a data set that covers all the world. And I don't know if you are familiar with Overture Maps. It's an initiative by a lot of companies, namely Meta or Microsoft. I'm going to load all the Overture buildings in the world into a tile set that was created previously with CARTO, and you're going to see how that looks in a minute. So first, and before we go crazy, let's hide these layers. And I also want to start with a new one. So Overture buildings, this is, I think originally this was 2 billion rows. So it was a huge data set. What we did before this demo is we created a tile set with CARTO. It's a process that took just a few minutes or hours in BigQuery. It's not like a super painful process. It's just pre-processing that you can do with CARTO and workflows. So what I'm doing here is registering over to Tileset. And in this case, we aggregated into hexagons into the H3 spatial index. So H3 tile source, tileset source. At this point, you already know we need to bring the credentials. And what I'm doing is bringing the entire tileset. So this tileset, I have it here. And now, of course, I need to create the layer. If you're gonna learn something out of this demo, it's gonna be sources and layers. I hope that concept is already clear, but it's super flexible, by the way. So now I need to create a new H3 tile layer. The ID is gonna be the Overture layer. The data comes from Overture. And let's see what we can do here, because I'm gonna do a few more things. I will use opacity. I will again elevate it based on the number of buildings. It says population, but I think it's the number of buildings in that specific cell. And I'm using color continuous instead of color bins. So basically saying, interpolate the colors across this range, and I'm using a different palette from OAuth colors. I just need to register color continuous. And I likely need to make it visible. If I wanted to build a layer selector, I would just do it with the filter about the layers that are visible. And before I could even finish the sentence, the entire dataset is loaded. There is no trick to this. You saw me destroy this demo, so it's not a video, and the performance is amazing. As you can see here, we have all the buildings in the world from Overture Maps, and this is blazing fast. It reaggregates data for each zoom level. I get all the higher zoom levels and all the lower zoom levels. And this dataset originally was 2 billion buildings. We just pre-process it with CARTO, then created tileset, and this tileset loads incredibly fast. And the last one I want to show you is raster data. So for rasters, we also have support. And the concept is the same. There's no need to do anything special. So let me register our source layer. I'll go a bit quicker. And I might have to register the source. And I will register import the tile layer. And then add it to our pretty long now list of layers. New source, new layer, raster source and raster tile layer. The concept is the same, but now we are going to style the layer based on the bands of the raster. In this case, this raster is elevation, only has one band. I should probably normalize these values so that they go from 0 to 250. But for this demo, this is enough. And you'll see in a minute that when I get to the range of this tile set, and I'm making this harder than it looks, I go into the US and here's my tiles, my raster source, and raster data can be also visualized super fast from CARTO and Google BigQuery. To get this source into BigQuery, we use the CARTO UI. I actually use Data Explorer, so this is super easy to do. And we built a geospatial application. I actually didn't use more than half an hour. I know some things were already tested, but the high-level message that I want to communicate here is I didn't have to do anything special to load millions of points. Dynamic tiling happened automatically. I didn't have to build an ETL pipeline. The data was already in BigQuery. Didn't need to do anything special for styling. Deck.gl already has a lot of potential and features. CARTO provides space map, so it's super easy. If I wanted to scale this, I could build tooltips, legends. The data is already here. This is just another application. This is vanilla JavaScript and TypeScript. If I wanted to use this in React, Next.js, Vue, Angular, I could totally do that. If I wanted to integrate Google Maps, I already know where to start. This is the foundations of all CARTO plus deck.gl large-scale cloud-native applications. So, of course, there can be questions at the end. And finally, our Data Explorer worked. And as you saw, we also have here the import and all the other features in CARTO. So this is how I imported the raster files to BigQuery. Before I finish, I wanted to cover a few things. One of them is that you have that gallery of examples available to you. If you want to do the same as I did, you can start from the same point, and those examples are perfectly replicable. I also wanted to show that there's another source that I didn't cover, which is boundaries. Boundaries is a source and it's a layer that covers that sort of postal code aggregations, census, block groups. Those are very hard usually. With CARTO and deck.gl, it's super easy thanks to these boundaries features. As you can see, what we do is we separate the data and the geometries. I don't want to go into a lot of detail, but we have an answer for this problem. CARTO provides known boundaries for boundaries visualizations. So if you need counties in the UK or zip codes in the US, you don't need to go anywhere. CARTO already provides those. And code-wise, this is very similar. We have the boundary query source that aggregates the geometries and the data, and then you have the tile layer. I don't want to go too quick here, so you all can read through this, but essentially same concept. Boundary source, vector layer. And the performance for this is amazing. This is the same type of demo. Visualizing data into postal codes and into counties is not easy. We are making it easy thanks to boundaries. Something else that I'm super excited is workflows via API. As you saw, workflows are no-code pipelines that do any kind of analysis. You can build your own with CARTO. You don't need to know SQL. You can just drag and drop components. The very cool thing is that you can execute them through an API. And there's this blog post that we can share that contains snippets of code about how to do this. And if you are wondering how to authenticate these applications, there are 3 methods. They are covered in our documentation. You have API access tokens for public applications. You have single page applications, OAuth flows for internal end users, and then machine to machine, which is sort of the jack of all trades for integrating your app in another app with authentication. If you wanted to use your own single sign-on, both OAuth clients can do that. But long story short, please integrate CARTO in your existing application. It should be very seamless. And in some cases, you might not even need a backend to do this. A glimpse into the roadmap. Things that are coming. I didn't include any widget, any chart. This is something that we will make very easy this year. We will make something that includes widgets, and those widgets will be synchronized with the visualizations. So any type of bar chart, formulas, histograms. We will include heat maps in the same way that I did the dynamic tile navigation. You will be able to build a heat map. And rasters, as you saw, I only had a few zoom levels. We are going to do support for raster pyramids. So super excited about the roadmap for developers. And we came to the end. Thank you so much for going through this webinar. I know that it was a lot of content, and I tried to include as many demos as possible. So while we wrap up, I will try to cover the question. All right, let's start with questions. First one, is there redraw speed on your example due to the vector tiles being pre-created? Not at all. I mean, when I use Tileset, so for us, a Tileset are vector tiles that are pre-created. All the other sources that you saw, they are not pre-created. This is what we call dynamic tiling, and I agree with you, they are super fast. Check it yourself. I would love to help you. Feel free to reach out later, but dynamic tiling works without any pre-generation. So I'm super excited about that. How come CARTO and deck.gl work together, especially since deck.gl is all open source? deck.gl was made open source, and now it's under a framework called BigQuery. So the governance is in BigQuery. CARTO is part of the technical steering committee, and we are lead maintainers. But the governance of deck.gl is not on CARTO. CARTO is just another contributor. The community of deck.gl is huge, and we love to help. Basically, we like benefiting and we like contributing back to the community. Yes, the recording is available when the webinar is done. We will make sure to follow up. Thank you. Thank you for attending. We use Next.js, which is pretty similar to React. Is it compatible? Yes, definitely. I did the demo precisely in mind, with having framework agnostic. I didn't include Next.js in the logos, I know, but it should be all compatible. the deck.gl community has examples with deck.gl with Next.js, so please check that out. Is it possible to add photorealistic 3D tiles from Google Maps? I love that one. Yes, we have an example and it looks super cool. I don't have that example yet in our documentation, but we will put that live very soon. How would you change the point radius based on the map zoom level? Good, very good question. So there are two methods. One of them is you can use pixels as your unit. So automatically by using pixels, you are already changing the point radius. Or you can fix it to meters. So depending on the visualization, one option would make sense more than the other. Then something else that you can do is basically make the point radius be a get. So get radius be a function based on the zoom level. So every time the layer is updated, you would essentially recalculate the point radius based on that zoom, and you could have different functions for each zoom level. I didn't have time to go into that level of detail, but definitely can be done with the deck.gl. Wow, this is a good one. What protection do you have against cross-site and SQL injection? What you saw is true, is queries that are going directly to the data warehouse. There are two layers of protection. The first one is those queries are not going directly from your front end to the data warehouse. They are going through our APIs, and then our APIs are contacting the data warehouse. There is no way you can do SQL injection because first, those queries are checked in our API, so they don't reach the data warehouse. And then they use natively the drivers and the interfaces available in your data warehouse. So when you are doing these kind of SQL queries, essentially you are using directly the SQL that is available to BigQuery, and there is no way that you can do injection in BigQuery, for example. Additionally, something that you could do, so on top of all the security that Google Cloud, for example, would bring, or Snowflake or Databricks plus CARTO, on top of that, I recommend that you give your tokens a specific SQL query grant. So that would be like a third layer of protection. You are saying, hey, this token can only run this query or can only access this table. Lastly, you could even set a specific roles for the connection in CARTO. So make the CARTO connection read-only from a DBA perspective and manage the connection permissions very granularly to sort of add another layer. Very interesting topic, of course, when we deal with this amount of sensitive data. Can your final map product be shared across institutions? Would it be possible for them to query individual points to return basic attributes? So yes, of course. This application that I built, I had it built so that it's sort of a public. If I send you the link, it should work. But of course, then I'm sharing I'm not making a private application. I'm making a public application. Yes, it would be possible for them to query individual points, but you would have to build that functionality using the CARTO APIs. It would be relatively simple. As I said, there are different methods for authentication. You could authenticate your app using single sign-on, and then have it ready only for specific customers or institutions. It would require some development, but we see that with a lot of customers. If you create your mapping builder, that can also be shared with other people. Can you explain why using a combination of a tileset and H3 index makes sense? That is a good one. So if you think about a tileset, it's just a performance visualization method strategy. So the only reason why I would do an H3 spatial index tileset is because exactly what you are mentioning already, which is on the different zoom levels, control the aggregation more granularly and have it be more performant. basically, if I'm doing H3 on the fly, or if I'm doing a very low resolution, sorry, a very high resolution, the performance might not be milliseconds. So by creating a tileset, I'm making sure that the aggregation is pre-generated for all zoom levels and not delegating that into the browser. For that dataset, the Overture Maps, I think the dynamic tiling would still make sense, but the tileset, as you saw, is incredibly fast. So that is the one case where combining spatial indexes and tilesets makes sense with huge data sets, billions of rows, as we discussed. But yeah, I actually I wanna try with that data set with dynamic tiling. It might be less performant, but it should still work at least for low resolutions. Can you analyze raster and point data from boundaries and then write the results back to source database? Yep. In fact, you could build a workflow that writes the result back to the database. So that would be my go-to. And what I like sharing is that those workflows can be scheduled. So imagine that you have a raster source that is updated daily, and then you have point data and boundaries that are never updated. I don't know what your scenario would be, and you want to write that back to the database. You would have a workflow that runs every day at the same hour, performs the analysis, performs the aggregation, saves it for future use. So I would totally use CARTO workflows for that. CARTO workflows also has an input. So if that analysis requires like an analyst defining an area, like, okay, do that analysis, but for this area, aggregate into this area, you could also do that using workflows. It seems that cartographic labeling is a place where deck.gl is less featured than other GIS software. You have to label multiple points in the map. If not today, it would be great to see an example of labeling in deck.gl. Okay, so if you go to deck.gl examples, to the link that I shared, there is a label examples. Please check that one. We also developed, and CARTO did this, we also developed a label collision extension. So we actually can put labels dynamically and have them not collide. I would like to speak with you because as I said, we are big contributors in deck.gl, and if you feel I know the perspective that you're bringing. deck.gl is relatively new compared to other visualization and GIS software. If you want a specific feature for labeling, I would love to bring that to deck.gl. So please reach out. My email is right here. Um, We'd love to speak about deck.gl and other compared to other GIS software. Would you need to pre-compute the data at its level of H3 resolution if you want different resolutions at different levels of zoom? Yeah. So when you do it dynamically, you're telling CARTO, please aggregate it or request this resolution. You would get kind of the same result based on your aggregation expression. Yeah, if you want a different if you wanted different resolutions at different levels of zoom, I would honestly, I mean, CARTO does already, it already scales the resolution up and down. You just set like the base resolution. But if you wanted to do that, what I would do is I would, using the same source or maybe using copies of that source, I would render different layers, different H3 layers based on the zoom level. So for example, you have the H3 dynamic tiling source and you have it with resolution aggregation 5, and then you display that layer zoom levels, 1 to 12. And then when you go higher, like closer in the map, you switch to a different source and a different level, and you optimize each of the visualization and sources for that one. I think pre-computing H3 layers or sources, it only makes sense when the dataset is huge and you have to really optimize each zoom level. But if you just need to do zoom-based styling, create 2 sources and 2 layers, and that should be it. Whoa, that was I really tried to stay on time, but well, I know this was a lot of content. Thank you so much for attending. I hope that you enjoyed. There are a few follow-up links that have been shared in the chat. And other than that, thank you for joining. Greetings to everyone from the different parts of the world. See you around. Thank you so much.